Hi guys, I just wanted to go over the assignment that's due today, Absolute Dating Reading Passage Fillable Slide. In order to view this document, once again, just click View, scroll down to Zoom, and then select 100% at least. In the document itself, if we go through and we look at the beginning, it asks us to describe what is carbon dating, radiocarbon dating, how is it useful to study fossils and rocks, what is a half-life, how is radiocarbon dating different from relative dating. All of that information can be found in the article on the first slide. So please use that. Try your best to put this information in your own words as much as you can. And then on the second part, that is the part that we're going to go over that I was concerned you may be struggling with as you are working through these problems. It states that a 10-gram sample of carbon-14 goes through 4 half-lives, decaying into a stable product. Carbon-14 decays into a stable product that is nitrogen-14, and it goes on to say, excuse me, that we need to make calculations so to complete the table below, describing the mass of carbon-14, the mass of the decay product, and the number of years that have passed. So the first two lines are done for us, which makes it really helpful. So we can kind of see a pattern that's going on here. For 0 half-lives, we have 10 grams of carbon-14 sample. 0 of it has decayed into nitrogen because this organism has not died yet. So therefore, the number of years since death, 0 has passed. However, after 1 half-life, so remember, a half-life is the amount of time it takes half of a radioactive sample like carbon-14 to decay into a stable sample, such as in this one, which is nitrogen-14. So after an organism has died, 5 grams of it still remains of that radioactive sample of carbon-14. However, the other half, nitrogen, has become nitrogen-14. So that's why 5 grams is still carbon, whereas 5 of the other grams that we originally started with is now nitrogen. The amount of time it takes for this to occur is 5,730 years. Now, in order to figure out the mass of carbon-14 sample that is left after 2 half-lives, literally all we have to do is look at what we have after the first half-life, which is 5 grams, and we will divide that by 2. Once we divide that by 2, this is what we come up with, and I encourage you guys to utilize your calculator just to make sure that your calculations are exact, because that's how I'm going to grade this assignment. Okay, so now that 2.5, we know after 2 half-lives, we've just broken this number down twice. So 10 divided in half one time is 5. When we take 5 and divide it by 2, then we have 2.5 grams. What do we do with the other 2.5 grams? Well, they don't just disappear. The remaining 2.5 grams are converted into nitrogen-14. That's why the amount of mass decay product after 2 half-lives of nitrogen-14 is now going to be 7.5 grams. Okay, good. Now, how did we figure out the number of years that it took for this to occur? We know that 1 half-life of carbon-14 is 5,000, equal to 5,730 years. So we're going to take this number and multiply it by 2 in order to get 11,460 years. All right, that I hope makes sense. Then when we look at 3 half-lives, what we're doing is we're looking at what we have remaining of carbon-14. We have 2.5 grams of carbon-14 sample remaining. We're going to divide that by 2. So feel free again, if this is difficult for you, to use your calculator. So 2.5 grams divided by 2 is equal to 1.25 grams. So we're going to record that. What happens to the remaining What happens to the remaining 1.25 is we add that on to our 7.5 grams of mass decay products. So that gets us to, if we take 7.5 and we add 1.25, that is going to give us our 8.75 grams of mass decay product. In order to calculate the number of years that have passed after 3 half-lives, after this sample of carbon-14 has gone through 3 half-lives, we are going to take our original number, 5,730, and we are going to divide it, or we are going to multiply that by 3. That is going to give us our 17,190 years in order to calculate the age of that sample once it's gone through 3 half-lives. So I hope that helps you guys to answer those questions on this assignment accurately. And then what I wanted to do next is, I know that on your quiz that you guys have today, the very last question is a little bit of a challenge. It asks you in particular, the half-life of carbon-14 is 5,000. So it's similar to this question. This question is saying the half-life of carbon-14 is 5,700 years. And then it asks, how much of a 6-gram sample will decay after 11,400 years? Now on your quiz, it says how much of a 4-gram sample will decay. So if you know how to do this problem, then you're going to definitely be able to tackle that number 4 quiz question that is posted for that absolute dating quiz today. So here's how we break it down. This is how we go about solving it. We know that 11,400 years is equal to 2 half-lives. How do we know that? Well, if we know that 1 half-life of carbon-14 is equal to 5,700 years, all we need to do is multiply that by 2 to figure out what 2 half-lives would equal, and that's where we get 11,400. Again, don't be ashamed to use your calculator in order to make sure your calculations are accurate. All right? Secondly, see, that does not answer our question. That just tells us that this carbon-14 has gone through 2 half-lives. We know that we need to figure out how much of a 6-gram sample will decay after this period of time, 11,400 years. In order to solve that, we have to do 2 more steps. We know that 6 grams to 3 grams, if we take 6 and we divide it in half, we have 3 grams. That is how much sample we have left during that 1 half-life. So when we go through 1 half-life, we have 3 grams left, right? If we go through 2 half-lives, we would take our 3 that we had remaining after the 1 half-life and divide it in half again. That would give us 1.5 grams during our second half-life. So overall, during this time period of 11,400 years, during these 2 half-lives, we need to add up the amount of grams that are decaying. So how much of this is decaying? All we're going to do is add this. 3 plus 1.5 gives us 4.5. Therefore, 4.5 grams are decaying after 11,400 years, or 2 half-lives. Please apply the steps of this to the different but very, very, very similar question that you have on your absolute dating quiz today, and you will do an excellent job. Also, use the information in the article that I just showed you on the first slide of that last assignment that we talked about first, in order to answer questions 1 through 3. So I hope this helps today for you to accomplish your work, and I hope you guys have a great weekend. Thanks.